Hello there, my name is Nettie, and I am starting this YouTube channel called Nam Tutoring. You can call it Nam Tutoring if you want, but it's just my initials. Anyway, I'm here with a Math Monday video with what I call a unit circle killer, but it's really just a chart of the values. I'm just going to show you how it's useful, and how you only really need these two charts and not the whole unit circle. I'm going to pause for a moment here so you can take a picture or write down the charts. If you need to pause the video, go ahead and pause it now. Alright, hopefully you wrote it all down. If not, you can pause it when I said to, and then you should be able to get it all down with great clarity. Alright, so to start, I call this Dr. Scott because of the first letters in all the words. As you can see in yellow there, it's degree, radian, sine, cosine, and tangent. Now, the reason why I wrote them out is because there are other trick things as well that we will get into in part 3 of this series here. But basically, this is all you need for most of your unit circle questions. First, I'm going to take you through the first quadrant of the unit circle. So first of all, unit circle, like any circle, is 360 degrees. So the first quarter is 90 degrees, because 360 divided by 4 is 90. So basically, for the first quadrant here, we only need 0 through 90 degrees, and then the corresponding radians is pi by 6 through pi by 2. Alright, and then basically, when asked for the sine of pi over 6, that would just be 1/2. And that's just kind of how you read it. So now the tricky part is using this when we're given something in another quadrant. So now for the other chart I have here, the mnemonic is all students take calculus. All students take calculus goes counterclockwise around the unit circle in each quadrant, and this tells you what is positive where. So basically, in the first quadrant, as we denoted it in our chart, all of the trig functions are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. In the fourth quadrant, only cosine is positive. Now I'm going to briefly go over why that makes sense. So I'm going to start with the second quadrant. So because sine is only depending on y, because y is positive in the second quadrant, so is sine. I'm going to skip the third quadrant for now and talk about cosine. In the fourth quadrant, x is still positive, and cosine is x over r. So cosine is positive in that fourth quadrant. Now in the third quadrant, tangent is y over x. So when you divide two negative numbers, you get a positive. So that's why tangent is positive in the third quadrant. All right, so now let's just practice a little bit here. All right, let's say I want to do tangent of negative pi over 6. So if it was positive pi over 6, we would just go to pi over 6 on our chart and find tangent there. But it's not quite that simple, because this time it's negative pi over 6. So because it's negative, when we go around the unit circle, instead, we go clockwise. Pi over 6 is in that first... Pi over 6 is in the first quadrant, so negative pi over 6 going backwards would be in the fourth quadrant. So tangent of negative pi over 6 is going to be negative. So whatever value tangent is of pi over 6, I have to make that negative. So tangent of negative pi over 6 is negative square root 3 over 3. Okay, so I erased the square root of 2 over 2 because that can be rewritten as 1 over root 2. So if you want a more advanced chart, I'm about to make one. 1 over square root of 2 is the same thing as square root of 2 over 2. And once I finish writing, I will show you that. Similarly, tangent of pi over 6 has that same property. So tangent is either tangent of pi over 6 is 1 over root 3 or root 3 over 3. Either of those. And I'm showing you these because depending on what you're doing, one form might be more useful than the other. Let's say for some reason you were multiplying tangent by root 3, that would immediately cancel with this 1 over root 3. Because root 3 divided by root 3 is a number divided by itself. A number divided by itself at any time is 1. All right? Unless you're dealing with an indeterminate form, but that's another part of calculus we can get into another time. All right, so here is my slightly more advanced chart. I went ahead and changed the color of tangent of pi over 6 just so it wasn't matching the other square root of 2 over 2's. And now I'm just going to add in some things to remember. All right, and if you want to write down this more advanced version, feel free to take a screenshot now or write it down. I will be posting every week new things that I think are useful or just answering your questions in the comments. I'm working on finding a good forum website where I can answer questions from, just so you can post like a PDF or something like that, or a picture of your problem, and then me or some other people can help you through that. All right. Well, basically, this is Dr. Scott. I hope you find it useful. Again, I'll be posting, I think, 2 more videos on this. I will definitely do more if people have more questions. But for now, this is all I'm going to do. Now I'm going to talk about how the roots are equating to the same thing. So the first fraction thing I'm going to deal with is 1 over root 2. And now math people just really don't like square roots in denominators. I don't know why. That's just the thing. So what we do is we use a rule of 1. So we happen to know a way to get rid of the root would be to multiply by root 2. But we can't just do that. We have to do something that equals 1. So to make it equal 1, we just put root 2 on top as well. So now we multiply the top 1 times root 2, and then we multiply root 2 times root 2 in the denominator. So 1 times root 2, that's just root 2. Root 2 times root 2, well, that is root 2 squared, and then what happens is the square root and the squared cancel. So then we're just left with square root of 2 over 2, which is what was in the unit circle chart. Or Dr. Scott, rather. All right, now I'm going to do the same exact process for 1 over root 3. Again, we have to do rule of 1, so we multiply by root 3 over root 3. Now what I did here is I wrote 1 times in the middle. That's fine too. You just need to be consistent. So in this case, it's going to be root 3 on top divided by root 3 squared, which is just 3. So on top we got root 3, and then our final answer is root 3 over 3. And that is how we generate that whole thing. Now I'm just going to go back to the page with all the stuff. Thank you so much for watching this long. If you made it through, great. If you have any questions at all, please leave them in the comments and I will address as many as I can, as soon as I can. And yeah, thank you for watching. Have a great day.